Okay, next video is explaining the demand side. So we've explained why, at least historically, prices have tend to be constant, and we suggested that they'll probably start going up steadily at some point in the not too distant future. 50, 100, 200 years. Hence, okay, it's a way off. But what about the quantity demanded? So if we remember iron, how might Solow, end of the world at hand, explain the constant expenditure share of iron? Let's have a look at the picture here again. So remember, very roughly for iron, we said GDP is growing like this, iron extraction or iron ore is growing like this, the price is more or less constant, and that means that the expenditure share, price times quantity over GDP, is more or less constant. How might Solow explain that? So here is Solow's picture. The red shows up really badly here. I'll try and make it show up better. Really doesn't like the red. The camera, never mind. How might Solow explain that? So here is iron, and its price, we've worked out that its price is not going up. So why do we end up using more iron over time? Solow framed everything in terms of how we would react if the price of a mineral went up really steeply. How would we deal with that? But if its price doesn't go up, what will we do? Well, one thing is we won't be too bothered about developing ways to use iron efficiently. Okay, because its price is not going up, whereas the price of labor, that does go up, right? The price of labor tends to go up at the same rate as GDP. GDP per person, anyway, goes up by 2%. The wages in the economy tend to go up by roughly 2% on average. Okay. So wages are going up, but the price of the iron is not going up. We don't bother too much about iron efficiency, but also productivity here is growing up. Our ability to make more and more stuff is going up. So we make more and more stuff. More iron gets sucked in. Plus, we don't shift out to non-iron demanding products. In fact, probably we shift the other way and demand more and more stuff which needs iron, because that stuff is getting cheaper. Okay. Plus, we don't particularly intensively look for alternatives to iron, because iron is not getting more expensive. Okay. So there's all these mechanisms which together tend to hold the share of expenditure on iron constant. Okay. So, what do we expect to happen as iron or other minerals start to run out? Well, then the price will start to rise, and then we expect the mechanisms to start working in the other direction. What's the sustainable rate of iron ore extraction? Well, if we take that literally in the very long run, it's zero, right? We can't carry on extracting and extracting and extracting for hundreds of thousands or millions of years. And we have millions of years on the Earth, right? Millions and millions of years. So clearly we need to go over to recycling, and then we expect then that we'll be making do with a roughly constant amount of iron in circulation, which we recycle, and then, like land, we expect its price to grow at the growth rate. of GDP, if there is growth in GDP. What's the sustainable rate of extraction of primary inputs for energy generation? Well, that's also 0. But we can't recycle fossil fuels, can we? To an extent, we can sort of reuse nuclear fuel, but in the end, we can't do that either. It means we have to use land to generate energy, but we've already talked about that. Okay. And there's also, of course, if over time, if one element gets in short supply before another, we can substitute between them. And that's one of the things that this Guller and Weinberg, well, I don't know how to pronounce it, Guller and Weinberg paper is about. Quite a nice, interesting paper, actually. Okay, so that's a sort of intro to explaining rising quantities. Then I think I'm going to stop this video, and then we'll have a second video looking at this model. It's going into a bit more detail. Yeah. Okie doke. So I'm going to stop the video there.